Hello students, welcome back to the 8th video of this playlist. So in this video, we will be solving question number 8 from the most recent Pure Mathematics 1 paper, which is October 2024 P1 paper. So let's see what's the question number 8 from this paper is about. Okay, so basically the concepts behind question number 8 is from integration part that has been discussed in chapter number 9 of your Pure Mathematics 1 textbook. So let's get started with question number 8. Okay, a curve C has equation y equals to f of x. Fine. The point P with x coordinate 3 lies on the curve C. Fine. Given f dash x equals to 4x squared plus kx plus 3, where k is a constant. So this is the gradient function for the curve C. It's given. The normal to C at P has equation y equals negative 1 over 24x plus 5. Fine. So part A is asking here to show that k equals to negative what? 5. So we need to show that this constant k is what? Negative 5. Fine. So here the gradient function is given and the equation for the normal, it's given, right? So using the gradient function, basically we can find out the gradient of the curve at any specific point, right? So since we know the x coordinate of point P, which is 3, so using this x coordinate we can find out the gradient of the curve C at point P, right? So let's find out f dash 3 would be what? 4x squared, that is 4 times 9, that would give you 36 plus 3k plus 3, that is equals to what? 39 plus thrice of k. Okay, so we got the gradient of the curve C at point P in terms of k. Fine. Now we know the equation of the normal to the curve C at point P, which is y equals to negative 1 over 24x plus 5. So the gradient of this normal is what? Negative 1 over 24. And we know that the gradient of the tangent will be what? Because tangent is perpendicular to the normal, right? So the gradient of the tangent will be the negative reciprocal of that. So we got the gradient of the tangent, and we know that the tangent has the same gradient as of the curve at the point where it is meeting that curve, right? So the gradient of the curve is what? So f dash 3 equals to what we can write? It is equals to just 24, negative reciprocal, right? So what we can write? 39 plus thrice of k equals to what? 24. Okay, so 3k equals to 24 minus 39, that would give you negative 15. So the value for k is what? Negative 5. And that's what exactly part A of question number 8 has looked for. Okay, next is part B. In part B, they are saying hence find f of x. So we got the value for k in part A, which is k equals to negative 5. So now they are saying what? We need to find out the original function, that is f of x. Fine. So f dash x, let's just put the value for k into the equation of f dash x. So you'll get 4x squared negative what? 5x, and then what? 5x plus 3, right? Okay, so if we want to find out f of x, then we want to what? We have to integrate f dash x, right? Okay, because f dash x has been found by differentiating the original function, right? So integration is a reverse process, so that's why we will integrate the we will integrate the gradient function. So if you integrate, what you will get? X cube, because in integration we add 1 with the power and then we use the new power to divide the coefficient. So 4/3, then here you will get x squared. We got the new power 2, so negative 5/2 plus 3x plus what? C. Fine. Okay, now we need to figure out the value for C. How can we find out the value for C? Okay, so the equation of the normal, it is known to us, right? This is negative 1/24x plus 5. We only know the x coordinate of point P, and since the normal to the curve C at P is its equation is known to us, so we can use this equation to figure out the y coordinate of the point P, because point P lies on this normal also, right? So if x equals to 3, then y would be negative 1/24 times 3 plus what? Negative 1/24 times 3 plus 5. So the y coordinate of point P, it is what? So at P we know that x equals to what? 3. Okay, so negative 1/8, 5 minus 1/8, that would give you 39/8. 39/8. So point P is what? 3 and 39/8. Now point P is a point that lies on f of x, so put the coordinates of the point P into the equation. So what you will get? 4/3 times 3 cube is what? 27 minus 5/2 times 9, 3 squared is 9, plus 9 plus c equals to 39/8. Now what we need? We need the value for c. So take all the constants to the right side. Okay, so 4/3 times 27, so that would give you 36 minus 45/2, which is 5/2 times 9, and then what? Plus 9, it is 45/2. So 39/8, 39/8 minus 45/2, that would give you what? 39/8 minus 45/2, that would give you negative 141/8. So we got the value for C, and that means we got the equation for the f of x, which is what? 4/3x cube, 4/3x cube, and then negative 5/2x squared, 5/2x squared, and then what? Negative 5/2x squared plus 3x plus thrice of x, negative 141/8. This is the equation of f of x, and that's what part B of question number 8 has asked for.